Hello, everyone, and thank you for joining. We have a few attendees yet to arrive, but I'm going to get started with some background information. My name is Leah Freeberg from Fluke Excelix, and you probably know Fluke as a test tool provider. You may also know that we produce some of the industry's favorite reliability tools, from infrared cameras to vibration meters, but you may not know that many of the measurements our tools collect now flow automatically into EAM systems of record. It happens via a framework that we call Fluke Excelix. Our goal is to better connect asset management data into existing asset management systems, and it all turns around best practices in condition-based maintenance. That's why this series of webinars explores reliability maintenance strategies, and that's why we feature speakers from a variety of expert backgrounds. Before the presentation, we have a few housekeeping items to go over. Today's session is being recorded, so your phone lines will be muted to minimize background noise. We will save time after the presentation for your questions. If you do have questions during the presentation, you're welcome to go use the questions feature on the GoToWebinar tool to submit questions as we go. So take a minute now to find the questions tool in your dashboard. At the end of the talk, I will share as many of your questions as time allows for our presenter to answer. And if we have unanswered questions at the end, we'll follow up with written answers in a Q&A. If you'd like to receive the slides from today's presentation, please let us know during the survey that will appear at the end of today's session. A recording of this webinar will be available on the excelix.com website within a day or two. All right, so that's it for the housekeeping items, and now for our main event. Today, we are very pleased to have Blair Fraser with us. Blair will be presenting about 6 myths about machine learning that M&R maintenance and reliability pros must overcome. Blair Fraser is a technology evangelist who has dedicated his career to combining sound reliability principles and processes with the latest technology to improve asset performance and uptime for customers globally. He's the co-founder and chief customer officer at Kortek Dai, a company focused on providing machine learning and artificial intelligence solutions for industrial and applications. Fraser is a certified reliability leader, CRL, and certified maintenance and reliability professional, CMRP, with more than 20 years of experience in the designing, commissioning, maintaining, and improving equipment and processes for the manufacturing industry. I know Blair is an active presenter, and his thoughts on machine learning applications for condition-based maintenance have been particularly well received this last year. I've seen lots and lots of comments from our community. So welcome, and thanks for coming on the show, Blair.
Thank you, Leah. Can you hear me okay?
I can.
Excellent. Well, thank you for that nice, warm introduction. I appreciate it. Thank you for everyone attending it, and for Fluke for having me on this. So we're going to spend the next 45 minutes or so talking about the common myths that I see coming across when we're implementing machine learning projects, specifically for maintenance and reliability. So who am I? The first thing that I am not is a data scientist. And the reason I put that at foremost is my education is in electrical engineering. Spent a lot of time on the shop floor turning wrenches, and moved up into some management positions across many different industries. And now I'm on the other side of the fence as a vendor. But the reason I highlight that I am not a data scientist is that when it comes, so if anyone doesn't know, data scientists are those people that create artificial intelligence solutions, typically coming from a statistical or analytical background. And so when it comes to data scientists, I'm not by any means an expert at it. Where I have spent the last 3 years is focusing on where to apply data science specifically for maintenance and reliability applications. 20 plus years in maintenance and reliability field, electrician by trade. And the reason I talk about my trade history is I believe artificial intelligence or machine learning is a lot like an apprentice. It is a shadow of yourself, if you will, when you build artificial intelligence. And just like an apprentice, you need to be able to give it feedback. You need to be able to teach it. You need to be able to give it new data or insights it's never seen before. And it's a continual process, just like you would as an apprentice. And as Leah mentioned, I'm the co-founder and chief customer officer at Kortek Dai. So just a brief introduction to Kortek Dai. We combine IoT and artificial intelligence to deliver applications that improve reliability, efficiency, quality of manufacturing. That's all we do is strictly manufacturing. We don't do anything in healthcare, financial, tech. And what we set out as a mission for our company is to put the power of AI in the hands of subject matter experts. So people like myself, is a joke inside of our company. If Blair can do it, anyone can do it. I'm not sure if I should take offense to that or not, but that's really what we're doing is we're enabling people like myself that I was not trained in data scientists. I can hack my way through code and Python and things like that, but I'm by no means an expert. So be able to enable people like me that design, operate, maintain pieces of equipment to be able to implement artificial intelligence solutions. So what gives me the right to talk to you? Hopefully there is some credibility here. So I spent most of my time in the maintenance and reliability domain. The last 3 years I spent in the data science, AI domain. So right in that middle, this is my home for the last 3 years, and I have learned to speak in increase. I ask why so many times in a day, and I ask why to the top data scientists in the world that I work with. Our chief data scientist is ranked 5th in the world at Kaggle. And if you don't know what I just said there, you're just like me when we first met him and got introduced when we were starting Kortek. I had no idea what Kaggle was. I invite you to go and look that up and just be cautious. There is a difference between Kaggle and Kaggle, but you'll understand of how respected and how well this person knows AI. So I get to sit beside him, our desks are side by side, and I turn to him and ask why a lot. And also beside some of the best M&R professionals in the world as well. So I take the knowledge I've learned from the data science side and I start asking questions to why from some of the leaders in the maintenance and reliability field. And the reality is I've learned through failure and success. So not everything has been rainbows and successes. There has been quite a bit of learning from failure. So this is a great opportunity just to check in with the audience, engage. Leah, do you mind if you walk us through this poll question?
Absolutely, I'd be happy to. So I'm going to launch a poll in just a moment where the audience will have the ability to answer these questions. As you can see, the first question here is how far along are you with machine learning applications at your facility? You should have the ability to now vote. Click on the choices you see on your screen. Are you at pilot completed and you're already implementing it, or you're in the process of? If so, congratulations. You do have a pilot program underway. You are at the research and planning stage. It's on your list, or it's not on your radar. So you do have to limit yourself to one answer, I'm afraid. And obviously, honesty is the best policy here, because Blair will take this information and apply it to how he coaches us in this session. And as you can tell, honesty is one of his traits, and it's well received here. So are you at a completed pilot stage, underway, in the research stage, on your list, or not on your radar? All right, I'm going to close, and I'm going to share the results. You should be able to see them now. And we have 5% of folks who have a program underway, 24% who are in the research and planning stage, 44% have it on their list, and 27% say it's not on your radar. However, you're here, so thank you for coming and listening today. No one has completed a pilot, and that is pretty much where the industry is at in general. So Blair, what do you think about that?
Yeah, I think it's a perfect representation of where we're seeing machine learning being applied. Those 5% that are doing that pilot program underway, congratulations. And I'm sure you can resonate with some, if not all, of the myths we're going to tackle today. So I think that's very representative of what we're seeing across all manufacturing industry verticals. It doesn't matter in metals and mining to oil and gas. We're seeing the same results across all of them.
Excellent. Well, audience, you just got called perfect first thing, so good job. I'm going to hide the results now and turn it back over to Blair.
Great. So we look at the first myth. The first fundamental myth that we come across is, I hear this all the time, and specifically after doing some sort of presentation, demonstration, ideation session, is this is great, but we're just not ready enough. We're not there. Maybe we'll be there next year, right? And I think it's no different than my New Year's resolution. This year's not the year. Maybe I'll do it next year, right? The reality is, I think most organizations are closer than they think to being ready, and majority of those are actually ready enough to start some sort of pilot project. And what's stopping a lot of us is figuring out what applications to start with. How do we even start with a machine learning program when it comes to maintenance reliability? And I start all my ideation sessions with our clients with this simple question. If you could ask a piece of equipment or an asset just one question, So imagine this, I know it's a bit far-fetched, but if you could just walk up to a piece of equipment and ask it a question and it had the ability to answer you, what would you ask it? And the majority of answers we get are three things. First one we get is, how are you feeling today? So when I picture, you're going into work on a Monday morning, you fist pump your piece of equipment, you say, hey, how you feeling today, right? The second one is, what are you going to do for me today? Another great question, but if we think very holistically at those two questions, they're very selfish. It's how you feeling because I need to make sure you run, and what are you going to do for me today? Again, is very, very selfish. The third one, which I get sometimes, which I think is the best question to ask when it comes to maintenance reliability, is, what could I do for you today? Right? Because really what you're trying to do is prevent and extend asset life. And I truly believe that our pieces of equipment are trying to answer us with the data we have. It's sending us the signals, my knee hurts, my neck hurts, those type of things, but we just don't have the ability to be able to decipher the code that is talking to us. So when we look at best applying AI, there's generally two avenues of going down. AI is an assistant, and I use AI as an assistant through email to schedule meetings and things like that, and it works great. It's just delegating those repetitive tasks. Great application, typically a very low ROI or lower ROI just because you're automating something you're already doing. Really, where I see it as a biggest player is AI as an extension of human intelligence. And this is why I'm one of the believers that when we talk about AI, it is artificial, of course, but it's really augmenting what we have to offer, right? So it's data analysis or creation of rules impossible for humans to create those amount of rules to decipher all that data that's going in. I think that's where we start applying this type of technology. We'll get the biggest return on investment. So hopefully everybody has seen a typical P to F curve. This is one by ARC Advisory Group, and I think it demonstrates visually where machine learning really comes in terms of maintenance and reliability. We're seeing an onset of machine learning being applied to what's being called predictive maintenance. Now, I can create a whole new webinar on my thoughts on actually calling it predictive maintenance, but for the sake of the term, let's just call it predictive maintenance. We have dealt where that typical P is in that P to F curve, and the P from defined by Nolan Heap was an identifiable physical condition which indicates that a functional failure is going to happen. So it's an identifiable physical condition. And really what happens at that stage is, in order for vibration to pick it up, in order for thermography to be able to detect it, in order to have particles and oil analysis to detect it, you already have to have some kind of physical condition happen, right, in order to cause those things to be able, those technologies to be able to pick it up. When we move back on that P to F curve, what is causing those failures to happen, right? Am I starving the pump? Am I bringing fluid into my compressor? Liquid carryover, for example. That's really where machine learning is coming in, to be able to detect those conditions that lead up to the point that causes that identifiable physical condition. And we look at business cases and best fit applications. So criteria number one is, if we're doing something with artificial intelligence, so an early detection or an outcome prediction, we're predicting what a value will be in the first place or will be in the future, it has to have valuable business impact, right? So linking it to a business case. And you're going to hear me say this quite a bit throughout this webinar, is I think the biggest value we bring as subject matter experts or M&R experts is turning a business problem into an analytical problem. So turning this business problem, I can't get this kind of output out of my plant. Well, what is the business problem of that? Well, these machines keep on breaking and I'm constantly firefighting and those things. So how do we turn that into a business problem? The second criteria, you have to be able to make decisions and be able to act on whatever AI is being able to do. Yes, if I can predict this piece of equipment is going to fail 2 hours from now, but there's nothing I can do about it, and you just have to sit there and watch it fail, there's not a lot of value in terms of that application, right? And we have to look at applications that it's impossible, like the patterns and correlations in that data is impossible for humans to be able to analyze, but the availability of machine learning can do that. And the number third is the availability of relevant data. And we get this all the time, is how much data do I need? How much data do I need to do a machine learning project? And that is one of the fundamental main myths we're gonna tackle today. But yes, you do need to have significant historical data that's available. Now, depending on the type of analytics you are doing, it depends on how much historical data you need. And when we get into things like baselining, so just learning the normal behavior and the normal operations, the normal health of your pieces of equipment, we just need a normal representation of that through all possible variations. So we don't need failure data and things like that. So there's not one size fits all in terms of, if you give me 3 years worth of historical data, you can build a great machine learning model. That's just simply not true. It's not in terabytes, months, years, days. It's really specific to the application. So when we look at, am I ready for machine learning, right? And if you look at studies being done, this happens to be the University of Tennessee Reliability and Maintainability Center, did a study about top quartile. So how much are the best performers spending on reactive maintenance and maintenance costs as a replacement asset value. And what we're seeing is that, generally speaking, you don't have to apply specific condition monitoring technologies before you can get to machine learning. You don't need to be best at planning and scheduling. You don't need to be best at any of those functional domains that fall within maintenance and reliability. But there is a fundamental base that needs to be established before I think you can take advantage of machine learning. And I'm going to give you an example. I was brought into a plant that wanted to very eagerly look at applying machine learning. And it was great. And where the initiative was coming from, it happened to be the CIO down, saying, we need to check this box off. We need to do AI by the end of the year in order to meet our corporate goals. So where they started was predictive maintenance, which is a great application. That's where everyone's driving me to. They called me in, hey, can we do predictive maintenance in here? And I said, sure. I would like just to get an idea of your facility. You mind if we do a walk around? And we did a walk around, and I couldn't distinguish whether it was a pile of clothes on the ground or it was an actual motor and pump. That's how dirty the facility was, right? So there wasn't a taxonomy. They had no idea how many assets they had and things like that, right? So politely, I said, I don't think machine learning is right for you until you do some of the basics, until you know, I'm not saying you have to have a bill of materials for every piece of equipment or identified every single piece of equipment in your facility down to the maintainable component, but at least have an idea, because there's a lot that they could do to get a return on their investments before machine learning. But most people, we've been doing this for a while. We have a generally standardized approach to doing maintenance and reliability, and machine learning would be a good fit to go on top of that to where you are in your journey. Do not think that you need to have an expert to work order management system or work execution program before you can implement machine learning. So, but here's the reality check, and this is where I see it a lot. If I'm able to predict things, a failure or condition that is not favorable for that piece of equipment, do you have the people and processes in place to do something about that? Right? I think the worst thing you can do is, I told you so. Yeah, I told you this was going to happen, right? That's not going to get you too far in terms of supporting these programs going forward. So if you can just ask yourself, if you have the ability to be able to react to something that's going to happen to change it using the output of machine learning. So now we get into number 2, which I already talked about, data problems. How much is enough? So a machine learning project is not dependent on enormous data sets with pre-existing failure data. So we go out there, and if you read like me, and it's actually funny because it's actually AI that's biasing what my news feed gives me. Everything is about AI, and I read a lot about it, and there's a common thread. Data is the new gold, which I think is from a 30,000 foot level, that's great, but we have a lot of data, and I'm going to go through how much data we have. But to me, data is not the new gold. The insights from that data is the new gold. And so data becomes, if you use a mining analogy, data becomes that ore we need to mine from the ground. And the analysis is then the processing of that ore to extract the gold from it. So really, I think we have enough data. We need to figure out how to get insights from that existing data. I want to give a throw out or a kudos to the Industrial Internet Consortium. If no one's heard of this, it is a great resource in terms of industrial analytics. They created a framework specifically for analytics, to guide and assist for decision makers in the development of essentially IIoT systems. And really what I love about this document is it looks at things from a persona or viewpoint point of view, all the way from people going to make decisions based on the insights to get from IT, operations, all those types of inputs or viewpoints that are required. It is completely free download. I invite you to go read this document. If there's one of the things, if you take away, and if you read this document, it's a relatively short read, and you can email me, I can send it to you. It is a great read to walk you through kind of the foundations and of how IIoT analytics can get applied. So what they talk about in the IIoT analytics framework is the types of analytics require different data. The first level of analytics is baseline analytics. So essentially what we're doing is baselining what it is right now. And sometimes you hear me say baselining, your ideal health or ideal performance of that piece of equipment or asset. But the reality is, if I go back to that PDF curve, how often do we have an asset working as designed, right? And I'm sure most of us know that, reliability as a whole cannot be improved, right? You have inherent reliability when you purchase that piece of equipment. And what we do, we do things to slowly chip away, sometimes not slowly, sometimes we take a chip, sometimes we take a sledgehammer to affect the reliability. It has everything to do with how we commission it, how we install it, how we designed it, obviously has a big impact of it, and how we maintain it. So the asset doesn't have to be, perfectly nameplate. What we're trying to do is find out where it is on that PDF curve. At what rate are we drifting away from what we have called its normal right now? In order to do that baseline data, as I was saying earlier, what you need is just a representation of that asset as it is now. So all the sensors that are on it, so the pressures, the levels, the temperatures, vibration, torque, current, whatever it is, baseline what that is normally. And the way I describe that is a lot like credit card fraud. We're just baselining, instead of our normal spending habits, we're doing it for pressure, temperature level, normal operations. Now there is a caveat here, because I've done projects where we've used as little as from 3 days to 3 weeks to baseline that piece of equipment. And I've used projects where we've had to use a year because the effect of seasonal changes on that piece of equipment, this happened to be an HVAC unit. And where I'm from, just outside of Toronto, there's a big difference between 40 degrees in the summer and minus 40 in the winter. So fundamentally, that piece of equipment reacts differently. That underlying pattern and relationship in its data is different based on those temperature differentiations. And if I was to train a model on baseline in the summer, it's going to be completely different than it is in the winter time. So those are the type of nuances that you got to think about. So we move from baseline analytics, and then we start to look at diagnostic analytics. That's when we're starting to look at specific, where we had to bring in fault data. So we had to look into identifying when exactly this piece of equipment failed, labeling that fault data, and bringing that diagnostic to get to root cause and things like that, which can very much be done, but it does require a new data set and start to think about where that fault data comes from. And then we get into prognostics, which I love this. And, a lot of the papers I read is about remaining useful life, right? So if you go back to that PNF curve and we say, hey, we're detecting an abnormal condition that's likely to cause cavitation. Everyone wants to get to, well, how long do I have left? How long does this piece of equipment have left, right? And the reality is, in order to get that, yes, remaining useful life is possible. We have done projects on haul trucks and things like that have been actually been able to predict that remaining useful life, but you need operational data, you need work order history, you need the fault data, and you need that baseline data. So when you're starting your analytics, I don't see why most people can't start just using that baseline analytics. And if you are more mature and you have your fault data, you have your CMMS in place, you have that data, you can look at diagnostics. Eventually, yes, everyone wants to get the prognostic, but I don't think trying to get there right out of the gate is the first application you could consider doing, unless you're very mature with your data governance program. So we are going to gauge the audience again. Leah, do you mind taking over?
Not at all. And I already have so many questions. It's great. So I'm going to launch our second poll here and take a moment to read. Are you currently getting useful asset condition insights from the data that you are collecting? Yes, maybe, or somewhat. No, we're working on it. Get back to us later. So think about the asset condition data that you're collecting right now, and are you getting useful insights from it? I'm going to give everyone a moment. Think about the data you're collecting. Is it getting you useful asset condition insights? Looks like we have just about all of our votes now. All right, 5 seconds and I close. Okay, I'm going to share the results. So 22% say that yes, they are getting useful asset condition insights from their data that they're collecting right now. 42% say somewhat. 22% say no. And 15% are the under construction. What do you think about that, Blair?
I think that's accurate, and hopefully those people that said somewhat and no, I think for the most part, I'm going to go into why. Looking at this, is there chances are there is valuable information in that insights. We just have to be able to get it out, and that's what we're going to go through.
All right. Okay, I'm going to hide this poll and turn it back to you.
Okay, so providing the ROI. So looking at the return on investment, is the reality is when we think about machine learning in particular, whenever we do a project or our customers implement a project, the first time they design and implement a model, they hit the deploy button and that model starts running and it's doing what it needs to do to detect anomalies or create predictions. There's an awkward pause, and what people expect is balloons to come up and confetti to drop from the sky, and when you deploy it, the lights to dim down. And there's a misconception about the investment level, the horsepower required, the compute resource required to be able to implement machine learning in particular. So when it comes to, we already discussed in brief about where to best apply AI or machine learning, but how do we get to the point where, okay, I've identified an asset, how do I justify that ROI? This is a great quote. I've scoured from the internet looking about this, and essentially what we're seeing is there's a lot of great implementations of AI. I think we're on the verge of seeing a lot more applications. I've been in this for 3 years, and I'm seeing more and more people come out sharing their story. Where we see a lot of the pitfalls, though, is people trying to boil the ocean instead of focusing on a specific project. So yes, AI has the ability and will disrupt our entire supply chain when it comes to manufacturing and energy production. Without a doubt, AI will have a place across every single aspect of what we do within our manufacturing environment. But if we go into a project saying, I want to optimize my entire supply chain with AI, it's possible. I mean, I'm not saying it's not possible, but in terms of that ROI, the ROI will be substantial, but that project length is going to be very, very long. And we have participated in projects where we have been on the project teams of some large boil the ocean transformations, and we've seen it. It is possible, but typically, how do you eat an elephant one bite at a time? That's typically where we see it, of knowing specifically the problem you want to solve with AI and going from there and building your way up and learning from that, and stepping stones in terms of getting to that full supply chain optimization with artificial intelligence. So when we look at starting an AI project, a lot of people come to us and say, we're starting to evaluate a platform to do artificial intelligence. I said, that's great, we're on board, let's throw our hat in the ring. And we start asking, what's your use case? Well, we don't know, but we want to start evaluating platforms. And our recommendation is always figure out that use case. Start with offline data. That's why when we create our platform, we created a whole, well, I should say whole separate, but a light version that allows you to deal with strictly offline data, because that data that you are collecting already in your process historian, in your CMMS, has valuable insights. Can we build a business case by baselining that piece of equipment, predicting, doing a failure prediction, predicting what the vibration is going to be in the future or something like that? Can we do that? Can we prove it without investing into a platform, without connecting to our what's being called OT system and CMMS systems and things like that, right? Because the data connection, the procurement process, all that stuff adds a lot of layers just to get to the point where you start to prove that value. So you don't have to stream data and invest in a platform to prove your use case. And that's fundamentally, and that's the offer I'll give to everyone on this after is it's great to see demos, it's great to see what is possible out there, but when you truly do a use case with your data, the traction and speed at which you can start to get consensus in terms of doing this becomes a lot faster. Okay, so this is a hot topic, and I love sensors. Let's just first of all say I love sensors. I love what I'm seeing when I walk around trade show floors in terms of all the vendors that are out there with new types of sensors, new ways of collecting data, new ways of sending data somewhere. But here's the reality, is study after study shows us that we're not using the data we have. This was a study from Gartner, says that 97% of data sits unused in an organization, right? And I think if you start to think of all the data sources, and I'll call them data lakes that you have in your facility, think about where they all are. Some of them are in Excel spreadsheets, some of them are handwritten notes, some of you right now have some of the best insights written down in your coverall pockets in a little notebook right now, right? For example, we did a project where we started analyzing some data from a CMMS, where we found the most influential or important comments or data from that was in the handwritten notes, or not the handwritten, the other field that you could actually just freehand type something in, right? So there's data there. So what I'm recommending is you don't need more data at this point. Again, I'm not against additional sensors. I believe they have a purpose, but they need to be there by design. I link it back to a run to failure strategy. Run to failure of a piece of equipment is a strategy in reliability and maintenance if you plan for it ahead of time, right? The whole point is, yes, I've identified the risk, identified the cost, and this makes sense just to run it until it craps out, right? But you can't go back and say, oh, I had that run to failure after the fact, right? Before doing all that work. So let's start looking at the data you have. And when we look at specifically, and I alluded to this when we started talking about the failure in that P to F curve. And this is from ARC Advisory saying 82% or more of damage to equipment is not caused by normal wear and tear. And we know that from Nolan Heaps and the basics of RCM, but it's process induced. So what is operation? How are we operating our piece of equipment? And we've seen that every time. Maybe we didn't let it fully warm up until we've started it. And how many times have we done that to affect the overall risk of that piece of equipment failing, right? So cavitation, no feed conditions in pumps, right? How many times have you heard that start up and go, oh, okay, oh, got to open that valve? What does that do to our piece of equipment? Obviously, it's reducing that life, right? So if you look at that 97% of data that we're not using yet, and if we tackle the 82% or more of damage to equipment is process induced, we have a lot of those process parameters that are there already. We've invested in truly in Industry 3.0 when we started doing heavy automation and sensoring for process, right? So we put levels, we put pressures, we put temperatures. We in some more than other in industries, we have instrumented the crap out of things, right? Let's start taking advantage of that. I truly believe that those sensors can be a better indicator of the health and performance of those pieces of equipment than adding additional sensors. So one thing I fundamentally had to learn, and I've struggled with it every day, is when is good enough? So any one of us has a natural tendency trying to make the perfect prediction. And if I can predict 2 days out what this value is going to be, and if I can predict that out 70% with an accuracy of 70%, is that good enough because right now I'm doing best guess, and typically human best guess is 50-50, sometimes even worse. When is good enough, right? If I can predict a failure 3 days in advance, but if I invest in addition with the sensors I have, but if I invest in additional sensors and I can get 7 days in advance, is it worth the cost of those additional sensors, right? So figuring out when is good enough. And this is fundamentally where, when we're doing projects specifically for maintenance and reliability, now we do get into process throughput and quality applications and things like that, but specifically my focus is on maintenance and reliability. The first thing I'm saying is, okay, do you have some sort of FMEA, RCM, some sort of guideline to how this piece of equipment fails? Yes, you can throw AI at any piece of equipment, but if you start linking it back to specific failure modes, and there's a lot of danger I feel happening in our industry with the onset of AI, and I think it's people not understanding or not coming from our background, then come to us and preach about AI, saying, I've heard this statement many times saying, with AI, you should never experience a failure again, right? And my eyes open wide, I pull my jaw from hitting the floor. Like, what is stopping lightning from hitting it? What is stopping Bob from running over with a forklift? Those type of things, right? So I think AI needs to be very a practical approach to how you're applying it. And if you're applying it to address specific failure modes, you are best off doing that way. So identify your failure modes or failure functions. Start with the data you have already first. See if you can solve that problem. See if you can get to an accurate result that is going to give you benefit before you determine if you need to complement that data with existing sensors. And I'm sure this is I can't see it, but I'm sure there's a lot of questions flowing in right now. So number 5, data scientists. And I love data scientists. As I say, I work with some of the best. About 90% of the time, I'm just going, I don't understand a darn thing you just said to me. Can you repeat that? But data scientists are one of the highest commodity jobs out there. In every report you see, it's an on-demand job, along with programmers, data engineers, and things like that. So they're hard to come by. And if we were fully honest, the data scientists, and if there is data scientists, I mean no harm by this, but if you think of if you went to school for a data scientist, you want to build AI, you can go across and you can apply data science across any industry. I'm not just talking about manufacturing, but any industry. You can go to Google, SpaceX, and those type of things, right? Manufacturing or energy is not the most sexiest, if you will, industries that are out there. And then we bring these data scientists in, and I think it's great. And I have seen organizations leverage data scientists, and they form a team, and they put some of their best engineers or maintenance people in with data scientists, and they essentially have to cross-train from each other, right? So data scientists are real. The average salary, I think, of a data scientist is $300,000, around that price point. But that's an experienced data scientist. But you start to think of that, and a lot of you might go, "Holy crap, I'm going to be a data scientist now," for that kind of salary. But they're hard to come by. It's hard to form a team. It's hard to train them on understanding our industry, and it's hard for us as M&R people to understand what they're doing, right? So in some cases, data scientists are required. And as I said, we've worked with some of the great data scientists on some large scale supply chain optimization projects. And that worked very, very well from that application point of view. But most of the time, often not, data scientists are not required. So when we look at data scientists in manufacturing, this happened to be one customer we were working with. What we found was that the entire site, and it was a pharmaceutical manufacturing site that had 1,300 employees, for every 162 subject matter experts, so those people that operate, maintain, design the piece of equipment to play in technical services and pharmaceutical manufacturing, there was one data scientist devoted to applying AI in that company. So when we look at the scale of artificial intelligence, because yes, we can create models, but as I was alluding to, as with the apprentice comment of machine learning, is we need to maintain them as well. It's not a one and done, right? If we think about it, if we baseline our piece of equipment and we overhaul that piece of equipment, we add a new component, we do something else to it, we run a new raw feed through it, that fundamental baseline changes, right? And we have to retrain a model. We have to retrain it to learn what is new. So then we have to get contractors back in, consultants back in, our data science teams back in. But what if we, as subject matter experts, can say, yeah, we overhauled this, so I'm going to let it run for a month. I'm going to select a month's worth of data, and I'm going to train it to learn what's new. That's really fundamentally what we see in industry. So Zhu Wang is our chief data scientist. I've already talked about who he is. When he first came on board, when we're asking him why join us when you're fifth in the world of what you can do, you have offers anywhere to go anywhere in the world to do artificial intelligence, why us? And he came up back with this comment: AI can be used to solve a lot of problems nowadays, but you're going to need domain expertise to find, define, and design the problem. That's what I was saying about turning a business problem into an analytical problem. And fundamentally, this is where most people fall, and it is probably the highlight of my job is determining what is the right question to ask AI. So AI is all about asking questions. It's all about determining the right question to ask so AI can give you that answer, right? And we call this, we've have used the term from Disney, Imagineering, right? Is we literally have a whiteboard the entire room and we just start to mock up problems. And if you've ever done the 5 why of root cause analysis, it's something similar to that. So answer the question, how are you feeling today? Well, it's just like going to the doctor. If you go on the doctor, he asks you how you're feeling, but you need to be more precise. How's your toes? How's your knee? How's your head? How's your heart rate? Right? There's a lot of things you need to go into in terms of defining that problem. And as you start asking the 5 whys of what you're trying to solve, you get more and more better at asking the right question for artificial intelligence. So some machine learning can be automated. If you do, and I highly recommend it, you read that IIC analytical framework. It talks about the algorithms that are available. So an algorithm is typically a statistical model that when you train it, so you apply your data to it, then it becomes an AI model. So there's algorithms out there, and a lot of them are open source that are really good at solving a specific problem. So anomaly detection, for example, a GMM model. I don't think we probably don't have enough time as it is as maintenance and reliability people, and I think we're expected to learn more and more and more as our profession matures. Now, do we have to learn which algorithms are better at which to solve this problem? I truly don't believe so. I think we can generalize, and that's what we tried to do across our platform, is specifically for manufacturing. If you're doing anomaly detection, these are the best models based on your best algorithms to stitch together to solve that problem. So a lot of it can be automated for the use cases in our industry, specifically for maintenance and reliability. Okay, so number 6, working with IT. And now I didn't have the, I had IT without the exclamation marks or the around it, so I said working with it, but working with IT. So, and typically, and I've seen this from my automation career, is typically I shouldn't say typically, sometimes we have to go to battle about implementing new things, and I start to understand why. So if IT owns the business systems, right, and most of the time you have a DMZ zone where automation owns the lower levels, and we start to put pieces of equipment onto our assets that skip the existing architecture and go right from taking a measurement and sending it to the cloud. Right? We're not necessarily creating an entry point, but as we look at maturing that data, at some point, we probably want to use that data for other things, bring it into our business intelligence systems, and we start connecting things together, which can be a big challenge. I fully believe that we can implement IIoT and AI without having to go to battle with information technology team and without having to rip and replace the existing infrastructure. So this is the current state of where we live in automation. If anyone is automation background, you probably know the Purdue model or ISA 95, where it talks in terms of levels, right? So machines sit at the bottom, we go up different levels, and we get all the way up to our ERP systems. So we have a very systematic or ladder approach that I always call it. Looks like snakes and ladders diagram to how information flows up from all the way on that piece of equipment from a PLC or a DCS all the way up until our desks and sometimes up into an ERP system. This is what the vision of Industry 4.0 is, as defined by the IRA, and it's essentially things talking to things, right? There's no structure to this. This thing can talk to this thing, and we're starting to see that outside of industry with our doorbells talking to our thermostats, talking to our Google Home Hub, those type of things. And we're seeing that, right? And we're also seeing some of the issues that causes of connecting things to things and not really having a means. So I truly believe, and we've seen this with the onset of foundation field bus and things like that, where we're starting to distribute some control and things like that. But to get from where we are current state and just go, screw my IT model, my network model, I'm just going to connect everything to everything and everything can talk to anything, is probably not the best way to go. So there is a structure for doing it, and we can coexist with IT and automation. And we start to hear words around intelligent edge and intelligent fog and cloud computing, which is a whole separate webinar on its own. But we can implement data flows, data architectures without breaking down that existing, I don't care if it's a 1 level, 2 level, 3 level, 4 level architecture that your current facility has. There's no reason why any IoT or AI project could not or should not fit within that existing architecture, and essentially future-proof it for the eventual days as we mature our network infrastructure to be future-proofed, if you will, when you start adding more devices, maybe reducing some layers and some complexity and things like that. Another big one is machine learning does not equal the cloud. You know, when I talk about this, and I've had some people literally look up from their desk when I start talking about AI. I'm like, right? The AI, yes, it does require compute resources. I'm a full believer in the cloud technology. I think it's very, very useful. I think it goes beyond just storage capabilities. It's really about about distributed computing, and it can exist, and you can leverage the cloud. But sometimes, and I don't always agree with it, but everyone thinks that their data has IP into it, right? I really don't see if your IP exists because of how your equipment is running, you might want to challenge that business model. But sometimes, because of the sort of industry you're in or the data we're collecting, we have to keep that data private, and there's some security concerns. It's not necessarily in the cloud, it's the pipeline of data to the cloud. You can run machine learning models completely on premises, data not having to leave your four walls. In fact, we have packaged it so it can run on a pretty standard server where you can run hundreds of models in real time on a typical server. So you don't need to think about if you're not mature enough. So, you know, if that's an IT battle to say, I know I need to start sending data to the cloud, who owns the cloud, who all that kind of stuff, you don't necessarily need to get there. I think it should be an ending point for all projects. But I realize and I see the value of being able to do projects, being able to do these pilots, scaling them up by keeping all your data in-house. So let's look at the summary. So number one was reliability and maturity. Reality is, since you're on this webinar, you're probably a great candidate for implementing a project in terms of using AI for M&R. Number two, you don't have enough data. And as I said, 98% of the data already exists. And for going after that 82% of process conditions, which then causes issues to our pieces of equipment, start with the data you have. Proving the ROI, you can do it without investing. I shouldn't say without investing. The biggest investment we always see is your time, right? Let's be a reality is unless you're lucky enough to get a job where you're just focusing on this type of technology or these type of pilot projects, which we have people seeing of titles of you know, M&R digital lighthouse person, right? And they're just looking at this technology, which would be great. You have a day job, so the biggest investment is going to be your time and resources. More sensors. Again, I think I've beaten this up enough. I'm a firm believer. I love sensors, but start with the data you have and then complement with additional sensors before you just start censoring. Data scientists, great partners. There are applications, low-hanging fruit, if you will, quick wins you can do without having the need of data scientists, and you can do it all without putting on your boxing gloves and start duking it out with IT. So my offer to you guys, if anyone's interested, we have tons of documentation, tons of white papers. You can find me speaking at a number of events that are recorded. But really, when it comes down to it, seeing is believing, actually doing it and proving it with your use case, your data, to get past those myths I just talked about, is the best way to do it. So you can imagine doing a project, as I said, like experimenting with your data. Can I baseline this? Can I detect this? Shoot me an email. Would love to hear from you. Love to hear your ideas. So here's my contact information, website. Best way to get in contact with me is through email or on LinkedIn. Very active on LinkedIn. Leah, I'll pass it over to you to help me with some of the questions.
Indeed. And at this point, everyone on the audience is welcome to find the question portion of your dashboard and type in questions, and we'll get to as many as we can. I got a whole bunch of questions about a particular part of the presentation, but I want to start back at the very beginning.
Mm-hmm.
Could you briefly give us your layman's distinction between AI and machine learning?
Yes. So the way I'm going to describe it from a layman's term, and I'm not putting in layman's term, I am a layman when it comes to this, is machine learning is a subset of artificial intelligence. In fact, the way I describe it is you can buy a vacuum cleaner right now that says AI enabled. And to get that label, if I was to create a simple rule, if pressure equals 56 PSI, then close valve, that is artificial intelligence. That is artificial intelligence I have made. I create a rule. Machine learning is a subset of artificial intelligence. It fits in with natural language processing, image recognition, deep learning, those type of things. It's a subset of artificial intelligence.
So, because you made a comment about midway through where you said, you take your algorithm and you apply your data, and there you go, you have AI. And I think a lot of people think of it as something more mystical than that.
Yeah, of leprechauns and unicorns,
Mm-hmm.
and it's not simply that. And we look at machine learning, and I'll make a statement here that if there's any data scientists on, they're going to cringe. But essentially, machine learning, to me, it is able to find those patterns and correlations in data that we as humans cannot see. So as humans, we can typically see 4 trends in time series data. So we can look at 4 trends on a chart and say this one went up, so this one went down, this one stayed the same, and we top out about 4 or 5. Whereas machine learning has the ability, tens, hundreds, thousands. It's not limited by technology. It's limited by the compute resource of the number of variables it's trying to analyze.
Okay, so it's running a program and it's looking for specific things because you've asked it a question and it's coming up with answers, and then it continues to process that and it gets more refined as it goes?
Correct.
Okay, all right. If you could go back to slide 15, that's where some of the questions started popping up because it's all about data, right? And we're thinking about assets. It's the 4 blue silos.
Yes,
There we
this is an
go.
interesting one. I had this into, I think, 10 separate slides, and I had to cut it down. Otherwise, I would have gone down a rabbit hole. Yes.
Right, because right away people start looking at this and they, okay, I'm relating to this. What they want to know is they understand that you're saying, okay, you have enough data to get started, but they're thinking like M&R people, and they're saying, well, I need specific data for my assets, right? And what if I have a critical asset? What if I need this? What if I need that? So if I was to summarize the questions, don't you need your historical data and your failure mode analysis to be able to get started, not just your baseline? Or what is that included in baseline maybe?
Yeah, so the answer is no, you do not. So that is, do you need precise failure data? The answer is no. So the analogy I give is if you were to, Fluke was very nice, and everyone that attended this webinar got a free Tesla. Okay, and particularly the autonomous vehicle or portion of a Tesla. And we said this is a free car. We haven't necessarily learned yet what a T-bone accident looks like. But once you get into that T-bone accident, you're never going to have that accident again, so we'll be able to learn from it. Right? Is the analogy. Would you get in that car? And yes, if you take me in the plant and we start doing it and you fail that very critical piece of equipment, I would love to see that specific failure pattern in that data. I would love it, right? I'm going to challenge that failures are like a snowflake, and we can get into machine learning and how much can you apply from one machine to the other, but chances are you might not have that data. So if you can baseline, if there is value of knowing when a piece of equipment is acting abnormal, then you don't need that data. So if I was to tell you, hey, this valve, this pressure is starting to act abnormal, I'm not saying this diaphragm on this valve or the spring is starting to fail, right? What I'm saying is generally this valve is starting to act abnormal. You should take a look at it. So you still need subject matter expertise. You still need people with subject matter expertise, domain knowledge to troubleshoot and identify it. With baseline data, I'm not going to get in and say you have a inter-race defect and you have 3 days left to live. It's, hey, something's abnormal with the current draw on this piece of, on this motor, for example. So if that's
Okay.
good enough, then that's where you can start.
Okay. I have some other questions that have to do with the model. In other words, so you're collecting data and you want to apply it to your PM program or your reliability program. How do you go about choosing the best model?
Yes. There's a little bit of statistics in terms of picking the best model. I don't want to describe it as brute force, but what we do is I call it a reverse hackathon, where you build multiple models based on the same training set and same testing set to find out which variables you need to include in that model to give you the output you want. So essentially what you're doing is creating different models using different featured inputs, so different variables to see what gives you the best model, and you're putting them to battle to see which one gives you the best results.
It feels like we have a gap there. And I'm looking at the questions and listening to what you're saying. It feels like we have a gap between what the M&R professionals are ready to do and what that requires.
To be able to build models or to determine which one's the best. There is a big gap, and I think that's fundamentally why I'm saying, we're not all going to be data scientists, right? I truly believe that if you know your pieces of equipment or assets, and if you can drag, drop, and click, you should be able to use machine learning in your M&R program. And you should know when a model is good. If I was to give you the results of 3 different models and you were to see the output of that, you should be able to tell based on your use case which model is good or not.
Okay. So again, having an M&R audience here, they are also digging a bit into the specific kinds of data that you find to be the best. So consider, like you said, this audience probably has a decent reliability program going. They're probably collecting a variety of data on the PF curve, right? So which of those data types do you find to be the best candidates for a pilot?
So first of all, from an asset point of view, any asset that has variability in its operations, right? So if it's a constant pump or motor, for example, rules and on top of vibration, on top of current is more than you probably need in terms of intelligence. So we're looking at variable piece of equipment. What makes that variable is the process conditions. So the process parameters, I think specifically from our process historians, OSI Pi, IP21, Wonderware, Factory Talk, things like that, have a wealth of information that I would gain from. Now, when it comes to condition monitoring, if we have extensive condition monitoring sensors that are out there, I can go down another rabbit hole of ultrasound versus vibration and things like that. But specifically, when we look at vibration analysis, a spectrum, so a raw spectrum from a vibration from an accelerometer, does not belong in a machine learning model. What you need to do is transform that data, and that's where the vendors out there are doing a good job of creating energy bands, as I would call them, 1 times RPM, peak to peak values, those type of things. Those become the features that should go into machine learning. And when you fundamentally combine the, say, a vibration reading with process parameters, that's when you get
that's yummy.
the magic.
Yep. And we have a lot of folks asking, so, can I go buy this right now? And I'm going to guess you're going to say, look at your data, look at your assets, look at what question you want to know. And are you already running software that's pulling that baseline interpretation out? Is that right?
Yeah, and I think that baseline can be from multiple data sources, right? And that data pipeline to connect that data is a big portion of that. And that's a whole separate conversation we need to have. But absolutely, I think that is the right thing to start to look at your data that you have. And if you can get that data into a CSV, which is essentially an Excel, from these various systems, you're in a great place to start.
Okay, I would love to keep asking you questions, but we are at the hour. If I could get you to forward all the way to the second to last slide. I want to thank everyone for attending today. I'm going to give Blair the rest of your questions and we'll follow up with some Q&A. You'll see that on our website. And if you, at the end of this webinar, if you will please click the survey and fill that out, we will make sure to get you a copy of Blair's slides. You'll also be able to go back to Fluke Accelix, and within a day or so, the recording of this webinar, including the poll questions, will be posted up there. I want to thank you very much, Blair, for talking to us today. Like I said, I have loads more questions. This was great. Thank you for
My
coming.
pleasure.
Very good. All right. Well, that concludes today's presentation. Thank you, everyone, and we'll see you next time.